Okay. Now, this linear programming, what we're doing here, is also called the method of corners. And here's why it's called the method of corners. Okay? Now we're going to get back to this objective function. Now, this is something I'm just throwing at you, I fully admit. But check out this objective function. It looks kind of like a line, but how many unknown things do I have on that line? 3. I've got a C, an X, and a Y.
Oh, is it like AX plus BY?
It looks like AX plus BY equals a number. Here's the deal, though. This C can actually be many different numbers. And I'll go ahead and tell you that if we pick different numbers for C, what we're doing is we're creating a set of parallel lines.
So if I were to say 6,
What is it solve for it now that you have 3 and 7?
It's a little weirder than that, because like 3x plus 2y equals 5 would get me one line. 3x plus 2y equals 7 would get me another line parallel to that. All these lines will be parallel. Now what we do is we figure out that this, how do I phrase this? Okay, this number C will have its highest and lowest values if we plug in the points from the corners of the shape we got, of our true region. So that's why you have to know the coordinates of all the corners or vertices of this region. One of them's at the origin, because we were shading quadrant 1. One of them's here, this 0, 10, because this is the lower of these two intercepts. One of them's here, 6.50, because we're shading this intercept. And one of them's here, the 3, 7. This is the one we had to find. But these are the corners of my shaded region. Now C, I apologize, Rodney, I should get you a steady cam, like the movies use. What I'm going to do now is I'm going to plug the X and Y coordinates of the corners of my shaded region into this, and I will get as many numbers as I have corners. If I plug in the origin, I get 0, correct? Is that right?
Sure.
Okay, please. Can you guys multiply by 0 and do some adding for me here?
I can,
Yeah.
yes,
Okay.
right.
All right. Now I'm going to plug in the x-intercept of my region. I'm going to get C equals 3 times 6.5 plus 2 times 0. That's going to go away. So 3, that's going to be 18 plus 1.5, 19.5, I believe. Is that correct?
Probably.
Yeah.
Okay, double check me. Then I'm going to plug in my 0, 10 up there. 3 times 0 plus 2 times 10. And that gets me 20. And then I'm going to plug in my 3, 7.
Wait, is this all for this one
Hold on,
problem?
what do you
It's all for this one problem.
Why?
3 times 3 plus 2 times 7. And this is 9 plus 14. And this will be 23. Is that correct?
It was like, why would you spend so much time doing one thing?
Okay, I'll try and answer that in a minute. And I'm not sure that I'll have time to do a good answer of it. But let me try. Give me a sec here to make sure everyone gets the process, okay?
You don't
All right.
understand it, right?
Right now you're supposed to be able to do it. You're not supposed to get the bigger picture yet. That is correct. I'll try and give you a hint. But you're given constraints. Let's review a sec. You're given constraints. You graph the constraints. The constraints are inequalities. So when you graph the constraints, you have to make sure you know which side to shade. The constraints in this case gave us a bounded region, a region that was all closed off. This region had corners, okay? You take the coordinates of the corners and you plug them into the objective function.
It's not quite right.
9 plus 14.
Oh, I'm just kidding.
Double check me.
Yeah, no, I did it wrong.
Okay. All right. So you take the corners, plug them into the objective function. You get a range of values. One of them will be the lowest possible value. One of them will be the highest possible value. Okay? For now, what you're going to be finding is the minimum and maximum values of this objective function. And you're going to be using these constraints to do it. Without doing an actual word problem example, which I don't have time for, Rodney, if you follow me back to the graph for a sec. Thank you. Let me give a hint of what this might be used for. All right. I am making two products. I am using the same machine to make two products. I'm working at a factory, okay? There's a limit to how much I can use these machines for. I'm using the same machines to make, I don't know, patio chairs and patio tables, okay? If I'm going to sell them, let's say I'm going to sell, these are really cheap things. Maybe they're for a dollhouse, I don't know. I'm going to sell one of them for $3 and one of them for $2. So my objective quantity would describe the money I would make for selling $3 chairs plus $2 tables. Hang on, let me finish this second. Ask it Dan. So this represents maybe my maximum profit. Okay? Can I make a negative number of chairs and tables? No. So my first constraints are going to be x and y are greater than 0. If I'm making anything, I'm making a positive number of them. Okay? These could represent all sorts of things. Maybe it takes 2 hours for the machine to make a table and 1 hour for a machine to make a chair, and the machine can only run 13 hours a day. Maybe I've got only 10 pounds of wood to work with a day. So the number of pounds, and it's a 1 pound table plus a 1 pound chair, has to be less than the 10 pounds of wood I have. So this graph would represent all of the different numbers of tables and chairs I could make in a day. Any point in here, I could make no chairs and no tables one day. That'd be 0, 0. I could make 1 table and 1 chair in a day. Any point in here would represent the number of tables and chairs I could make. I cannot go out of this region, because maybe that means I don't have enough hours on the machine, and the machine can't run enough hours in a day to make 20 tables and 20 chairs. Or I don't have enough wood every day to make 20 tables and 20 chairs. So this, Rodney, you're doing great. So this region represents all the combinations of what I can make. And this equation of the constraint, the objective function, would represent all the possibilities of profit. And that 23 down there would be the biggest amount of profit I could make. I have to make 3 tables and 7 chairs to get the most profit out of it. We'll go over this later. Okay, I don't expect you to understand this word problem now. But this actually represents a real range of possibilities. If you want to do anything, actually make anything, actually manufacture anything, okay, you are going to have constraints on your manufacturing. Some of these constraints are common sense. You can't make a negative number of items. Okay? Some of these constraints will be very hard to set up as linear graphs, because you'll have to figure out what the problem's saying in terms of, okay, I have to have less than 10 pounds of wood. How do I write an equation to that? But this represents real, actual situations, and people actually do this to figure out how many widgets should I make and how many gadgets should I make to maximize my profits, assuming